The amazing
All right.
Spencer.
All right, we're gonna go ahead and crank this thing out real quick. So I'm gonna do number 1 and 2, and Brady's gonna hit 3, 4, and 5. And all right, so number 1, it's asking for the different blood cross, and so A, it wants to know possible genotypes for the child, mom, and dad. And so the child, you're gonna have little I, little r, and then M. And the mom will be little I, little r, M, N. And then the dad will be A-type blood, but it's also going to have heterozygous, so it'll have a little I in it to contribute to the child. And then it'll have a heterozygous for the R as well. And then it'll be an M. And then B, it's asking for what proportion of the children will be born to a man with that certain genotype and a woman with that certain genotype. And the answer, all you have to do is monohybrid cross for each of the 3 traits. And you'll get 1 out of 32. If you multiply across, you'll get a quarter times half. And that ends up just being about a little over 3%. C, it asks kind of the same thing. You're just going to cross 2 different genotypes, and you end up getting 3 out of 64. You're going to multiply a quarter times 3/4 times a quarter, and that'll end up being just over 4%. And then D, the answer is just the man is not correct. He could be the father. One of the reasons why is because his blood type, he could have heterozygous, so he could donate that little I, along with the mother being heterozygous for her blood type, could donate the little I, which could produce an O-type blood for the child. Also, the rhesus factor, he could be heterozygous as well, and so could the mother. And then with the M and N locus, he's N and the mother's MN, so they could definitely produce an MN. So those are the answers for number 1. And then number 2, let me flip to my notes. It just asks for certain genotypes of the parents that produce the phenotype ratios. So you kind of just do a test cross and just kind of trial and error, just figure out what works and what doesn't. And so for A, you're going to have a heterozygous R and homozygous recessive R, and that'll cross with heterozygous P and a homozygous recessive P. For B, you want 3 rows, 1 single, so you're going to have heterozygous R for both, and then you're going to have all homozygous recessive Ps, and that'll give you that. C, you want 1 rows, 1 single, so you're going to do heterozygous R cross with homozygous recessive R, and once again, you're going to have all heterozygous recessive Ps. D, you want 3 walnut and 1 rose, and so that'll give you homozygous dominant Rs, and you'll have a heterozygous R, and you're going to cross that with heterozygous P and another heterozygous P. So that'll get you that. And then Brady can take it from here.
All right, so for number 3, it's talking about the horses, and it says something about explain the inheritance of the coat color, and that just has to do with incomplete dominance, which is heterozygous displays phenotype intermediate between 2 homozygous classes, which is how you end up with the palomino in this case. Part B is indicate the genotypes. So if you look at it, you're going to end up with Cremello being recessive Cs. You're going to end up chestnut being homozygous Cs, and palomino is going to be heterozygous Cs. And when you cross that out, everything works out on that problem. And then 4 is fill in the blanks, and I'm just going to read off the answers. We have, let's see, glycosyl transferase, galactose, and then for B, over dominance. C is incomplete penetrance. D is epistasis. E is PKU. F is lethal and lethal. G, the phenotype ratio is 60% dextral and 40% sinistral, and that's because it's a mother inheritance question, maternal inheritance. The phenotype for H is 40% green and 60% white, and that's also because of maternal inheritance. And then 5 is pretty much trial and error, but if you look what you need, you can pretty much figure it out. You just do monohybrid crosses, and you do it until you get what it's asking you to get. And I guess that's the best way to describe that question.
That's how you do it, yo.
That's how you do
All right,
it.
thanks for watching.